the word factor, and you might be familiar with the word prime. Well, factors are the numbers that we multiply together to get a product, or a new number. And prime numbers are numbers whose only factors are 1 and itself. Well, let's take a look at an example, and we'll use a relatively small number, like the number 6. We can think of the number 6 as being the product of the numbers 2 and 3. That means that 2 times 3 equals 6. Well, 2 is a prime number, and 3 is also a prime number. So we can say that the prime factorization of 6 is simply 2 times 3. No other number has exactly this prime factorization. This is unique to 6. Let's take a look at a larger number. Let's say the number 24. And we're going to find the prime factorization of 24 by using a factor tree. So to find the first 2 branches, you have to think of any 2 numbers that multiply to 24. And actually we have a lot of choices. We have 2 times 12, or 3 times 8, or 4 times 6. I'm going to go with 4 times 6, but you could have used any of those. Now we have to decide if 4 or 6 are prime. As it turns out, neither one of these numbers is prime. So we need more branches on our tree. So let's start with the number 4. Well, we can think of the number 4 as being the product of 2 times 2. And 2 is a prime number. So that's as far as we need to go on this side of the tree. Now let's take a look at the number 6. And we know that the number 6 is the product of 2 and 3. And both 2 and 3 are prime. So our factor tree is complete. And now we can write our prime factors. We have 2 times 2 times 2 times 3. Another way to write 2 times 2 times 2 is 2 to the 3rd power. So we have 2 to the 3rd power times 3. And that is the unique prime factorization for the number 24. No other number will have this prime factorization. Well, earlier I said that we could have used any 2 numbers that multiplied to 24. I just happened to choose 4 and 6. But let's try another pair. Let's see what happens if we try 3 times 8. This time, one of our numbers is prime. The number 3 is prime. So we're done with this side of the factor tree. But we can simplify the number 8 a little bit further. We can say that 8 is the product of 2 and 4. And we know that 2 is prime, so this branch is complete. 4 isn't prime, so we have to go a little bit further. And we know that 4 equals 2 times 2. And 2 is prime. And now we can write our prime factorization. And again, we have 2 times 2 times 2, so that's 2 to the 3rd power. And we also have the number 3, so we write times 3. And you'll notice that the prime factorization that we ended up with when we chose 3 times 8 is exactly the same as the one we got when we used 4 times 6. So now that we know something about prime factorization, let's tackle the original question. What is the prime factorization of 525? So let's begin by writing the number to be factored at the top. And we'll put in our 2 branches. So what will our first 2 factors be? Well, this is where knowing your divisibility rules would be really helpful. I noticed that the last digit is a 5. So that means that this number must be divisible by 5. And that means that 5 must be a factor. When I divide 5 into 525, I find that the other factor must be 105. So 5 times 105 equals 525. Now the number 5 is prime, so that means that this branch is complete. But we still have to factor 105. Well, the last digit of this number is also a 5, so we could use 5 again. And when I divide 5 into 105, I get the number 21. So we know 5 is prime, so we're done with this branch. And now we have to factor 21. Well, 21 is the product of 3 and 7, and both of those numbers are prime. So now we have all of our prime numbers. So we can write our prime factorization as 3 times 5 times 5 times 7. And we can simplify this a little bit more by writing 5 times 5 as 5 squared. So this is the same as 3 times 5 to the second power, or 5 squared, times 7. And that's the unique prime factorization of the number 525.